Hello everyone, in this video we're going to talk about how to graph a quadratic function that is in intercept form. So what is intercept form? What does it look like? We see it at the top of our screen right here. It is f of x equals a times x minus p times x minus q. So if we think back to factoring quadratics or factoring trinomials, it kind of looks like we're in factored form here. And we are, it's just when we're graphing it as a function, we call it intercept form, okay? So a couple properties about our graph before we jump into our example. P and Q are the x-intercepts of our graph. So if we look at our diagram over here, we've got P and we've got Q, and those are just the x-intercepts of our graph. Notice when it's in our standard equation up here, it's x minus P and x minus Q. So it's going to kind of be like opposite of what it looks like there. So if we have x minus 4, then we're actually going to have an x-intercept at 4. And if we have x plus 2, we're actually going to have an x-intercept at negative 2. Okay, so it's kind of opposite of what it looks like. Our axis of symmetry is halfway between P and Q. So whatever our x-intercepts are, add those together, divide by 2. That's going to give us our axis of symmetry. Okay, for our parabola, it is either going to open up or down, and that depends on what a is. So if a is greater than 0, a positive number, our parabola is going to open up. We're going to have a minimum value. If a is less than 0, our parabola is going to open down, and we would have a maximum value. Okay, so we'll take a look at our example here. We'll graph one in this video. So we have f of x equals negative 1/3 times x minus 4 times x plus 2. So the first thing I want to identify, I see p and q. So p we're going to say is 4, and q we're going to say is negative 2, right? So remember, it's kind of opposite of what it looks like because it started off as x minus p and x minus q, right? So if I have x minus 4, then we plugged in a 4 for p. And if we have x plus 2, we plugged in a negative 2 for q, right? So that's kind of why it's 4 and negative 2. So now we can go ahead and plot those points because that would be 4, 0 and negative 2, 0. So negative 2, 0 and 4, 0. All right, so now what we can do is find our axis of symmetry because it is located halfway between negative 2 and 4. So for our axis, we can say it is equal to negative 2 plus 4 divided by 2. Well, negative 2 plus 4 is 2, and 2 divided by 2 is 1. So our axis of symmetry is just x equals 1. So for right now, I'm going to draw a vertical line through x equals 1, make it a dashed line, and that will be our axis of symmetry. Okay, so now we can find the vertex of our parabola. Because we know the x value of it, we can plug 1 into our equation and find the y value. So now we're going to find the f of 1, and we have negative 1/3 times 1 minus 4 times 1 plus 2. So we're just going to simplify this. 1 minus 4 would be negative 3, and 1 plus 2 would be positive 3. So now we have negative 1/3 times negative 9, and that's going to give us a positive 3. So what we have done here is we have now found our vertex, 1, 3. So now we can plot that, 1, 3, and now we can draw our parabola. Okay, so we kind of line it up here where we want it. Looks pretty good, and put our arrows on the end, and we've got it, right? So that's how you graph a quadratic function in intercept form.